Which of the accompanying graphs describe one-to-one functions? Explain your answers. Well, first of all, we have to recall what it means for a graph to be a one-to-one function. Well, a one-to-one function has two important characteristics. Number one, equal inputs always have the same output. And number two, equal outputs always have the same input. On a graph, we can determine if equal inputs always have the same output by applying the vertical line test. The vertical line test says that if every vertical line intersects a graph at no more than one point, then the graph represents a function. So let's apply the vertical line test to our three graphs. We'll start with graph A. For graph A, we see that a vertical line either does not pass through the graph or passes through the graph in just one point. Every vertical line intersects the graph at no more than one point, so graph A represents a function. What about graph B? Well, again, we see that a vertical line intersects the graph either no times or one time, so graph B is the graph of a function. What about graph C? Well, we see that a vertical line either does not intersect the graph, or it intersects the graph once, or it intersects twice. Since it is possible for a vertical line to intersect the graph at more than one point, graph C does not represent a function. That means that equal inputs can have different outputs. So graph C is not a one-to-one function. Graph C does not pass the vertical line test, so it is not a one-to-one function. Graphs A and B do pass the vertical line test, so it is possible that they could be one-to-one. But we have to check our second property of one-to-one functions. We need to check and make sure that equal outputs always have the same input. The way that we can do that graphically is to apply the horizontal line test. The horizontal line test says that if every horizontal line intersects the graph of a function f at most once, then f is a one-to-one function. So let's apply the horizontal line test to the two remaining graphs. For graph A, we see that a horizontal line might not intersect the graph at all. It might intersect the graph at one point, but it might intersect the graph at 2 points. It is not the case that the horizontal line intersects the graph at most once. Therefore, this function is not one-to-one. Graph A does not pass the horizontal line test, so it is not a one-to-one function. Well, finally, what about graph B? We see that a horizontal line can intersect the graph at one point, and as we slide the horizontal line up and down, we see that everywhere the horizontal line intersects at just one point. Now it is a little bit tricky along the x-axis. The curve flattens out. It appears that it might touch the horizontal line more than once. But we're going to assume that this function is always decreasing, that it does flatten out, but that it always decreases. So since that's the case, our horizontal line never intersects the graph more than once. This graph passes the horizontal line test. Since the graph passes both the vertical and the horizontal line test, it is the graph of a one-to-one function.